Welcome to this interesting and simple topic, vectors. So the way this topic is going to be delivered is we're going to start with we're going to discuss it into two videos. So in the first video, which is this one, we're going to take a look at properties of vectors or introduction to vectors. Then we'll also take a look at vector geometry, which is how to deal with vectors on graphs. Then we'll end with addition and subtraction of vectors. Then in the next video, we're going to take a look at two types of vectors, which are called position and column vectors. Then we'll finish with solving geometric problems, which come in paper 2. So a vector is a quantity with both magnitude and direction. Magnitude simply means size. So any quantity that has size and direction is called a vector. Then the opposite of a vector is a scalar, which is just a quantity that has size only. So whatever we're going to be studying, you should always be thinking about magnitude and direction. Let's say we have got this quantity here. So you can see that it is pointing this direction. So depending on the length, for example, we can say that this is 40 meters east. So the 40 meters part is the size and the east is the direction. So it's showing us that it has given us the direction and of course the quantity. We can also have something like this, which you can say is 20 meters east. So the quantity has changed, but the direction is the same. So in talking about vectors, we talk about quantity. And so let's say we've got this situation. We've got a point A and a point B. Then we've got this vector. So we usually represent vector by a line and an arrow that shows direction. So this can be vector D. So to say it's vector D, we just write D with a line, a small line here. Then you can tell that this is vector. Sometimes we write vectors from where they are starting from to where they are ending, like AB. Then on top we put an arrow that shows direction. So let's say we have this vector. If that was AB, then what could this vector be? So you can see that the magnitude is just the same as the previous one, but the direction has been reversed. It was moving from here to here, now it's moving from here to here. With that being said, this vector can be negative D if that one was D. So this is how we show change of direction. Positive is one direction, the opposite direction is denoted using negative. So if this was AB, then the fact that the direction has changed, then this is negative AB. Or we can just start from we can just say it's coming from B going to A. So we can say BA. So negative AB is BA. So whenever we're dealing with vectors, if they are CD, then the opposite, which is supposed to be negative CD, it's going to be DC. Hope you get it. So negative AB is just the same as reversing the letters BA. So more on vector notation. Let's say this vector AB on graphs, we usually represent vectors by X and Y, where X is the number of units or boxes it has covered on the X-axis, and Y is the number of boxes it has covered on the Y-axis. So we say AB is X, Y. So in this case, how many boxes it has covered in the X-axis? It's 1, 2, 3, 4. So on the X we put 4. Then in the Y it hasn't moved any in the Y, it hasn't covered any box in the Y, so it's 0. So this is 4, 0. So movement to the right and up are always positive, that's the agreed standard. Then movement down and to the left are negative. So let's say we have this vector here, AB. What is its how do we write it? So AB, by the way, if you write vectors like this in columns, they are called column vectors. Of course, we're going to do something that is dedicated to column vectors, but these are called column vectors. So to write this as a column vector, we count the number of boxes that's moved in the X. So it started from here and ended here. So if we just count in the x, it has moved 1, 2. Then in the y, 1, 2. So it's 2 and 2. What about this one? So this one is the same as that one, but it is in the negative. It's just opposite. It's just the opposite of that one. So what you can do, you can just add negatives to the numbers we did count at first, or what you can do is you can see where it's starting from and where it's going. So starting from where it's starting from, it has gone down to, that is in the y. Actually, I'll start with x. So we can say it has gone to the x2 to the left. So 1, 2. So it's -2. Then down also 1, 2, -2. So it's -2, -2. What about this one? So again, it's starting from here and going here according to the arrow. So in the x, it's 1, 2. Then in the y, it's 1, 2, 3, 4, 5. But it is down one, so it's negative in the y. So this is going to be 2, 2 negative. What about this one? So this one, if we count in the x, there is no any movement in the x. It doesn't move to the left or right. Then in the y, it has moved down. So we're talking about negatives. 1, 2, 3, 4. So it's going to be 0, -4. What about this one? Again, this one in the x. This one, I think we dealt it, the first one, where we had 4 movements in the x and no movement in the y. So 4, 0. So now there's this concept of distance of a vector. So the distance of a vector is denoted using these symbols, which means magnitude. So the magnitude of a vector AB is denoted by this, and the formula is x squared plus y squared, then square root. So you get the x value squared and the y value squared, then you square root everything. That's the magnitude of AB. So in this case, we have 4 and 0. So we square 4 and 0, we're going to get 16. We square root 16, we'll get 4, and we add units at the end. What's the magnitude? What is the magnitude of this vector? So we discussed that the value of this vector is -2, -2. Okay, with that, to find the magnitude, we just have to put -2 where x is and -2 where y is, and we're going to have 8. And if it's paper 1, you can just finish it there, square root of 8 units. If it's paper 2, of course, you have to leave it with 3. Well, you have to leave it in 3 significant figures, as it is advised when you're writing an exam. So then we are going to look at equality of vectors. How are two vectors equal? So let's say we have these vectors. So we've got vector A, B, C, D, and E. So which vectors are equal? So if you look at the principle is two vectors are equal if they have the same magnitude and same direction. Same magnitude and same direction. That's the only way two vectors can be equal. With that being said, we can see that A and B are equal because if you look at them at the value of A, it's 2x and 1y. Even B is 2x and 1y. They have the same magnitude and same direction, so these vectors are equal. But A and C are not equal because A, you can see, is shorter than C, meaning that C has a bigger magnitude than A. Okay, two vectors are equal only if their magnitude are the same and their direction are the same. If you look at A and D, they're not equal. Why? Because they have the same length, which means their magnitude is the same, but they're pointing in different direction. This one is pointing this direction, this one is pointing this direction. If you try to get the value of this vector, you're going to discover that it's going to be it has started from here, since the arrow is pointing to the left. So in the x, it will move -2, and in the y, it will move -1. Well, this one in the x starts from here, it moves 1, 2, and in the y it moves 1. So these vectors are not the same. They can only be the same if they have the same magnitude and same direction. The same is true between A and E. They are pointing in completely different directions. Finally, we look at addition and subtraction of vectors. How do you add vectors on graphs? So to add vectors A and B, first you have to draw vector A, and then you have to draw vector B where vector A ends. finally you have to connect where vector A starts to where vector B ends. So the vector that you're going to draw and connecting, that's your answer on graphs. Okay, do this. You write vector B where vector A ends. Vector A ends here, so that's where you start vector B. You just write it in the way it is, the same direction it was taking. So it was going up. I mean, it was going down, so it's going down. So when you are done to find the answer, you draw a line from where vector A started to where vector B ended. That answer is called the resultant vector, and it's what you is in short is the answer, the number you get when you add. So even if you want to add it in terms of mathematics, you just count, you just get the value for that vector. Let me just see. So this vector, so the answer to vector A and vector B is this vector in blue. So you can just count the number of boxes in the x, which is 2, then in the y is 0. So the resultant of vector A and vector B, or the answer you get when you add vector A and vector B, is 2, 0. So, but usually we're talking about graphs, so you just connect where this starts and where the second vector ends. That's your answer, and the direction will be from where the first vector started to where the second vector ended. So this is B and A. Next, we look at subtraction, which is just the opposite of addition. To subtract vectors A and B, as in A minus B, what you do is you just add A and B, but B you take it as negative. So you write A minus B in the form of A plus open bracket minus B cross bracket. So what you're going to do is, this minus means vector B, you have to reverse it. So once you reverse vector B, you can now do like we did in addition. So this vector B has to be reversed. To reverse vector B, it is moving 2 units down and 0 unit left or right. So you just add negatives, mean that it will move sorry, let me say that it is moving 2 units down, so when you reverse it, it will be moving 2 units up. Okay, so it will be just the same vector but pointing upwards. Okay, mathematically, if you look at numbers, this vector is going down, so it's -2, 0. So just reverse the signs. So -2 will become 2, but 0, nothing's going to happen to it because 0 has no sign. But if it was another number like 5, it could have become -5. Okay, but we're talking about graphs here, we're not talking about numbers. That's why I'm not illustrating. I just want you to have an idea of what happens when you are viewing vectors in terms of graphs. So this will change direction, so it will be the same vector but with a direction changed. So once you do that, you now do as we did in addition. So you get this, you draw this vector, the first vector, then you draw this vector in the reverse form. So where the first vector ends, that's why you start the second vector. So let me just illustrate this. So if you have vector A, you can draw vector B. Once you have vector B, you can connect vector A and vector, sorry, this is not vector B, it's vector -B. It has been reversed. So you connect vector A and vector -B. Okay, so you're going to have this. So this is your resultant, A minus. So this marks the end of part 1, the graphical approach. In part 2, we're going to take a look at column vector and position vectors, which have a tendency of coming in paper 1. Then after that, we're going to take a look at graphical problems which are in paper 2. Happy solving.